Hi all. If, like me, you like to run your railroad with a timetable, it's quite useful to have a fast clock that you can control and then everybody can see. And now with the new version of software for the Z21 and a new DCC spec, it's actually possible to sniff the fast clock time from the DCC, from your rails, and I'll show you how. Here's the basic setup I use. We have a Z21 in the upper left corner and a DC signal to the track or to a DCC bus and an Arduino. I built my own Arduino based decoders, but you can use any Arduino with a proper DCC shield. And I use an I2C display. They're pretty cheap, the OLEDs. And in the lower left corner we have the C21 maintenance. It's what you use right now to start and stop the clock and set the time and how fast the time should go. That talks to the Z21 using the network. When I develop decoders using Arduino, I use the NMRA DCC library you can see here. I have the latest one installed. Unfortunately, they don't support the fast clock yet, but there are reasonably easy way to fix that. First, you need to find your NMRA DCC library. It's usually in a folder called libraries or some such next to your Arduino project. In that you find the CPP file and the .h file. Let's start with the CPP file. You can see here you need to add these 4 or 5 lines, and over on the right you can see approximately where in the file you can find the place where to put them. In the H file you go down to the bottom and you add the line you can see here. That should do it. Now let's look at the actual decoder implementation in Arduino. We include the usual stuff, the Arduino and the NMRA DCC. We include the TWI, which is for the I2C connection to the display. And we use the U8 G2 lid for actually drawing on the display. The software version is just wanted by DCC. Here we instantiate the DCC variable and the display itself. And here is some variables for remembering what time it is, the latest time we have received from the controller. And a bunch of data that we'll look at later. It's for the analog clock. In the setup part, we just tell DCC what pin to use for interrupt. And then we init the DCC and tells it we want to be an accessory decoder. And then we initialize the U8 G2 display. In the loop, we always, when using DCC, we always start by calling DCC process. Then we have some, I've made some fun here. After 7 o'clock we switch to a analog clock, just to show that we can do that too. This function, notify Fastclock, is the one we added to the NMRA display, or the NMRA library just 2 minutes ago. It's called whenever NMRA finds a time packet. Down here, if we have found a new time, the new clock will be true, and we go on to show either the digital or the analog clock. So for the digital clock, we format the string with the hours and minutes and use UAG2 to display it. If we want an analog clock, we draw a circle and then we calculate the position of each of the hands using all the numbers we saw at the top of the page, and draw 2 lines, and that's it. Now we just need to make sure that the Z21 actually has the software that can push out the time codes. So check that you have firmware version 1.4.3 or later. If you don't, you need the newest Z1 maintenance tool, which is 1.18, and then use the firmware update to update your Z21 to 1.4.3. When you've done that, you have this. You can start and stop the clock here. You can see here you can send out Fastclock on DCC, and here you can set how fast it should go. It's ridiculously fast. Usually in Fremo we use somewhere between 3 and 4.5, but here you can only set whole numbers, but you can set 64, which is ridiculous. I don't know what they were thinking. If you want to run on your model railroads a reasonable timetable, you should run at 3 or 4, I'd say. Happy coding, and thanks for watching.